Okay, today we're going to look at standard form, and this is what we use to write very, very large numbers or very, very tiny numbers in a more in an easier way to write without having all the zeros that we've got on there. Okay, so if you look at this first one, we've got 436 million. It's easier if we write it in standard form rather than if we write 436 million. Okay, and you can imagine if we had a million, trillion, billion, then that would obviously be a lot of zeros for us to write. Okay, so that's the whole point of standard form. Now, everything I say to you today is actually mathematically slightly incorrect because I'm going to be moving the decimal point, and really the decimal point stays as a placeholder and the numbers move either side. Okay, now the reason I'm doing this, and it's against what is mathematically correct and I mathematically should teach you, is because I think you'll find it easier if you move the decimal point rather than the numbers. Okay, so just be aware, I've not lost my marbles, I do know what you're meant to be doing. But this is how I would like you to do it. Okay, right, so hopefully this is a bit of revision, and you'll recall that to write a number in standard form, we are always writing it as a number times by a power of 10, okay, so that we've got those zeros as placeholders, and the initial number always has to be between, and this is a key point that you need to be aware of, always has to be between 1 and 10, okay, it can't be 0 point something, it has to be between 1 and 10, okay, including 1, not including 10. So here we go. So we're going to make this number, we've got 436 million, we're going to try and make this number between 1 and 10. So I'm going to put the decimal point in inverted commas. Mathematically that is incorrect, but that's what we're going to do. We're going to put the decimal point in this number to make it between 1 and 10. Okay, so that would be 4.36 times 10 to the power of. Okay, this is how your standard form always looks. It's a number between 1 and 10 times 10 to the power of something, okay? Now, if there were a decimal point here, in order for this number to be this, we would have to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8. We'd have to move it 8 places. So that is that written in standard form, okay? If you have your calculator, hopefully this will work, and you write 436 million in your calculator, it did not work. It sometimes gives it to you in standard form, okay? But equally, if we did it the other way around, if we wrote 4.36 times 10 to the power of 8, it would come up with 436 million, okay? Obviously, this is quite a childlike way to do it with the hops, how many hops we've got to do. I would think of it as, okay, I've got to do 2 hops to get out of there, and then another 6 hops, because there's 6 zeros. So 2 hops to get into the zeros, there's 6 zeros, so that's 8 hops in total. Okay? Right, then this one, we need to make this number between 1 and 10, so that'll be 8.9. Okay? And then we've got to count how many hops we've got to get to where the decimal point actually is. Okay? Obviously, in reality, we're picking up all these numbers and moving them to the left of the decimal point. The decimal point stays in the same place. But for ease, we are moving the decimal point today. Okay, so if my decimal point's here, it's got to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's times 10 to the power of minus 9. Why is it minus 9? Well, this is a very big number. This is a very tiny number. So if it's a tiny number, it's obviously going to be smaller than this number between 1 and 10. So it's going to be times 10 to the power of minus whatever. Okay? And this one between 1 and 10 is 5.783. Unless it tells you to do it to 3 sig fig, you must have all the numbers they put on. Okay? So 5.783, we've got to do 3 hops to get out of there, and then we've got 7 zeros, so that's 10 in total. So it's 5.783 times 10 to the 10. Okay? This one, we need it to be between 1 and 10, so that would be the number 8. There's no point, it's just 8. Times 10 to the, here's where the 8 would be, 1, 2, 3, 4, 5, it's a very, very small number, so it's 8 times 10 to the negative 5. Okay, and the last one, make it between 1 and 10, 5 million, so it's 5 times 10, because there's no decimal point, this is nice and easy, you can just count how many zeros, because we've already made the hop, there's no hops to get out of the decimal place, so it's 6 zeros, so it's 5 times 10 to the 6. Okay, hopefully that makes sense. Okay, right, you then have, going back the other way, writing them as ordinary numbers. So this one should be nice and easy. We've got 5 and 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Obviously, put your 1,000 markers on because that makes it easier. 500 million. Okay. This one, the easiest way to think about it, I would say, is I've got to do one hop to get out my decimal place, and then I must have 4 hops remaining, so I've got 4 zeros, so it's 320,000. Okay, this one, I've got to go, we're going back the other way, so I'm moving my decimal point 3 places, 1, 2, 3, that's where the decimal point goes, so it's 0.0046, okay, my decimal point has done, even though it hasn't, but for now, it has done 3 hops, okay, 3 hops, one of those hops is to get at the beginning of the 4, so then we've got 2 zeros in between, okay, 5.72, I need 1 hop to get out of the 5, and then there must be 5 remaining hops, so we must have 5 more zeros, 5, 7, 2, let's check, here's my decimal point, 1, 2, 3, 4, 5, 6, lovely jubbly, 0.30572. Okay, hopefully that makes sense. Right, we're now going to look at multiplying and dividing in standard form. And you need to use a bit of the stuff that we have done on indices in order to make this easier, okay? So, when we are multiplying in standard form, luckily nice and easy. Okay, so we've got some very massive number times some other very massive number, okay? You could write them as ordinary numbers first and then multiply them. Some of you might find that easier. There is a quicker way though. Let's do it now. So we're going to take our 2 numbers and you multiply your 2 numbers. So 5 times 3 is 15. And then we've got these 10s to worry about. These 10 to the power of 8 times 10 to the power of 5. Now the reason we can do this is because it doesn't matter what order we times things in. So I'm choosing to times my 2 numbers, 5 times 3, 15, and then times my 10s, which are the powers. Okay? When you multiply, hopefully we remember, you add your powers. Okay? So we've got 10 to the 8 times 10 to the 5 is 10 to the power of 8 plus 5, which is 13. Okay, happy days, there we go. Now, this obviously has to be in standard form. Now, it's not in standard form because this is not between 1 and 10. To make it between 1 and 10 then, I need to put in a decimal point, 1.5, and then that means that if I was going to write this as an ordinary number, here I'd be adding 13 zeros. Here I've got to do an extra hop and then add 13 zeros. So it's times 10 to the power of 14. Okay, similarly, 4.2 times 2 is 8.4. Add your powers, 10 to the 7 times 10 to the 6 is 10 to the 13. Is that in standard form? Yes, because that number is between 1 and 10. Okay, again, 5 times 6 is 30. 10 to the 9 times 10 to the 8 is 10 to the 17. Is that in standard form? No. How do I make it in standard form? Well, you put in your decimal point. Obviously, we wouldn't write 3.0, so it's just going to be 3 times 10 to the 18. I need to add 1 extra 0. 1 more hop. Okay, here we go with dividing. So, same thing again. Divide your numbers to start with. So, 4.8 divided by 2 is 2.4. And then when we divide, hopefully you will recall from our work on powers, when we divide, we subtract our powers. So we're going to do 4.8 divided by 2 is 2.4, and then we've got 10 to the 10 divided by 10 to the 4 is 10 to the 6. So it's 2.4 times 10 to the 6. Is that in standard form? Yes, it is. Hunky-dory. Okay, then 7.2 divided by 4. Don't forget when you divide by 4, you half it and half it again. So I think of, okay, 72 divided by 2 is 36. Divided by 2 is 18. So 7.2 divided by 4 is 1.8. Then we're subtracting our powers. 1.8 times 10 to the 3. Okay, last one. 3.4 times 10 to the 9 divided by 2 times 10 to the negative 3. So 3.4 divided by 2 is hopefully 1.7. Then we've got 9 minus 3. What happens when you minus something? It becomes a plus. So it becomes 10 to the 9 times 10 to the negative 3. No, divided by 10 to the negative 3 is 10 to the 9 plus 3, which is 12. So it's 1.7 times 10 to the 12. Okay, that's adding and subtracting. Nope, that's multiplying and dividing in standard form. Let's quickly do adding and subtracting. Okay, now this is a little bit trickier. This is the trickiest ones, I would say. When you are doing it, there are two ways you can do it. You can either write these as ordinary numbers and add them. Okay, so the first one, we would have 42 with 6 zeros, i.e. 42 million. And the next one, we'd have 31 with 5 zeros, i.e. 3,100,000. Then you could add them. And then you could write that in standard form. 4.51 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. Okay? However, it is easier, you can do it in a simpler steps. Let me show you here. Okay, what I would like you to do is I would like you to make whichever your biggest power is, I would like you to make that smaller. So here we're going to make this 10 to the 6. So I want these 10s to have the same power. So this is 10 to the 6, that's the smallest, so we're going to make our biggest power of 10 smaller, we're going to make it 10 to the 6. In order to do that, this must have to be 42. If I'm going to do one fewer hop, I need to do the hop, which is 42, and then I'd have to add 6 zeros. Okay? You then add your two numbers, just like we did on the last one. Okay, when we were multiplying and dividing, you add your two numbers. So 42 plus 3.1 is 45.1. Your 10 to the power stays the same, so it's 10 to the power of 6 because they're both the same power. And then you have to put that in standard form. It's not in standard form because that is not between 1 and 10. So you put the decimal point over 1, which means that I have to increase my hops. So it's 4.51 times 10 to the 7. Obviously, these are the same. It doesn't matter which way you do it as long as you are happy. Okay? Same with subtracting then. So we're going to make our big power smaller. So that's 56 times 10 to the 8. Take away 3.1 times 10 to the 8. Subtract your numbers. So 56 take away 3.1 is 52.9. Your 10 to the 8 stays the same. And then make it in standard form. So it's 5.29 times 10 to the 9. Okay, it would have worked if you'd have written them out as numbers, done column subtraction. Okay? Right, and the last one, 8.2 times 10 to the 5 plus 4.1 times 10 to the 6. Make our big power smaller, so that can stay the same. This becomes 41 times 10 to the 5. Add your two numbers, so you get 49.2 times 10 to the 5, and then put it in standard form, 4.292, times 10 to the 6.